Hello everyone, I hope you're doing great and fabulous. So we're going to look at adding inventory and balancing chemical equations. So to do this, I'd like you to look at this first question here. Does this equation obey the law of conservation of mass? Why or why not? You look at this, notice a couple things. First of all, that there are elements on the left side and the right side. Are the formulas the same on the left and on the right? No, absolutely not. Formulas are not the same on the left and the right. You can see here you've got copper, we got sulfur, we got sodium, we got chlorine, we got chlorine. Law of conservation of mass would say the mass on the reactant side is going to equal the mass on the product side. Now, we've got a bunch of different elements here. And so if you had, for example, H2O solid, and you melted that, and it became H2O liquid, do you think the mass on the reactant side would equal the mass on the product side? Do you think the mass would change when it went through a phase change? And the answer, as we know, is no, it should not change. It should stay the same. So if we look at this, the mass on the left does equal the mass on the right. Many of you said no. The reason why not is, well, we've got only one Cl here. We've got two of them here. They can't have the same mass if there's not the same amount. And two NAs are here, and only one Na is here. We got an S, we got an S, we got Cu and Cu. So it looks like this one does not obey the law of conservation of mass. So we're going to look at how we can balance atoms in a chemical equation. So to do this, we need to know a balanced chemical equation is one that shows the true mathematical relationship between the reactants and the products in a chemical reaction. Looking at this equation here. So we're looking at balanced chemical equations, and a balanced chemical equation is one that shows the true mathematical relationship between the reactants and products in a chemical reaction. So if we look here at this reaction, this is methane being added to oxygen, producing carbon dioxide and water. If we inventory this, first of all, here you'll see there's one carbon, there's 4 hydrogens. Yeah, there's 2 oxygens on the left side, reactant side. On the product side, you'll see a carbon, 2 oxygens attached to it, and here we have 2 hydrogens attached to an individual oxygen. We've got 1, 2, 3 oxygens on this side, 1, 2 hydrogens, and 1 carbon. This side we've got 2 oxygens, so we can see very quickly that one thing that is equal on both sides is the number of carbons. So what we can do is we can add more to make sure that the 2 sides are equal. Now if we look here, we are like, oh, we don't have enough oxygens, let's just add a single oxygen like this. That would seem to work out. However, the problem is oxygen is not found by itself, so we can't just add one of these to fix this. Same thing's true with these. The formulas have to be the same, so we can only add one of these, one of these, one of these, or one of those to balance the equation. On this side, I've got 4 white ones, 4 H's. On this side, I've got 2. So I'm going to add 2 more to the right side by adding a water molecule like that. Now the carbons are equal, the hydrogens are equal. The last thing we're looking at is the oxygens. We've got 1, 2, 3, 4 here, and only 2 here. So if I had them connected together, an O2 molecule like that, that would produce give us another oxygen in the reactant side. Now if we count them up, we've got 1 carbon, 4 of the hydrogens, 4 of the oxygens, 1, 2, 3, 4 of the oxygen. This equation now is balanced. In the equation, we write a large number here to represent the 2 units. The 2 units of oxygen, the 2 units of water that are being used in that chemical reaction. Those large numbers are called coefficients. The small numbers for the formulas are called subscripts. So whenever you're writing a formula, you need to have a correct chemical formula first with the correct subscripts. Then when you balance the equation, you only change the coefficients. Coefficients are the numbers in front of the chemical formulas of the reactants and products. They show the correct ratio to which the reactants combine to form the products. Coefficients in the chemical equation indicate how many units of an element or a compound you have. Equations must obey the law of conservation of mass. Here you've got 1 unit of Mg and 2 of O. 1 unit of Mg, 1 of O. Whole number coefficients are added to balance the equations. First step is to write the correct formulas for reactants on the left side and the correct formulas for the products on the right side. So if you're given an equation like this, the formulas we would need to know, we would know the formula for oxygen, the formula for carbon dioxide, and the formula for water. And to form is our arrow. There's our plus sign, there's our plus sign. And we also need to know the formula for ether, which we will learn how to get that information. So, oxygen we should be able to do, carbon dioxide, and water we shall be able to do at this time. Ethane's formula is C2H6. There's oxygen, carbon dioxide, and water. Second step is to change numbers in front of the formulas to make the number of atoms. Each element the same on both sides. Do not change the subscripts. Do not. Change the subscripts. It's only done very, very beginning. So this is an example of what not to do. Don't do this. No. These are not the same thing. This is ethane, this is something completely different. Start by balancing those elements that appear in only one reactant and one product. So here, start with C or H, but not O. So 2 carbons on the left, 1 on the right. Multiply CO2 by 2. 6 hydrogens, 2 hydrogens. Multiply H2O by 3. Here's our balanced equation so far. So if we take that equation, then we look here at the same equation. We got oxygen. That appears in 2 or more reactants or products. So then we look at our oxygens. We got 2 on the left, 2 times 2, then we got to multiply by the coefficient, and 3 times 1. A total of 7 oxygens on the right. To determine what number to put in front of the O2, we write what we want on the top and what we have on the bottom. So we multiply O2 by 7 halves. We want 7, we only have 2. So there we go. There's our equation with a fraction. Remove the fraction, multiply both sides by 2. 2 goes all the way through. That's our balanced chemical equation. Then check to make sure you have the same number of each type of atom on both sides of the equation. 4 C's, 12 H's, 4 O's, reactants, products. Do they match up? Equal, you now have a balanced chemical equation. So here, let's practice this equation. Take a moment, balance the equation. So we got 2 N's, 2 plus 2, 4 O's, it's now balanced. Please balance this equation. Next check-in question, balance this equation with iron and oxygen. We'll balance this equation. And balance this equation. So the last balance would be this one here. So how do you balance atoms in a chemical equation? In order for matter to be conserved, the number of atoms on both sides of the chemical equation must be equal. When a chemical equation is balanced, which indicates the molecules or units or moles of each substance take part in the reaction, how many molecules or moles or units of products are produced.